Hello everyone, it's December 10th. Alright, today I'm doing this on my new laptop. It arrived, I finally get a setup. Time Machine is quite useful. I don't have to reset anything. I just, I think spent an hour, maybe an hour and a half, porting from my previous laptop all the way to here. The previous was on M1 chip, this one is M3, and it worked seamlessly. And I got a 14-inch because 16 inch is way too expensive. I feel like I don't need that much real estate on the laptop screen because I have two monitors. And so far, it's the same user experience. I don't feel any foreign any because I have my workflow and this does pretty well. I think the only thing that's kind of bothering me is the real estate because the screen is smaller. So all the previous settings on the font size and everything just looks weird. It looks like crowded, and I mean it cannot show as much as it used to. So I'm not sure. Maybe I should change the resolution, get a little bit more to show up. Um, we'll see. We'll see how I feel. But anyway, so what are you gonna do today? Yeah, I have no hope of this. So my theory is LeetCode trying to get more people to sign up. I mean, of course, it's their business, right? They need more people to sign up to their premium, and daily challenge is a very good way to get people hooked, right? It's like say you have um, a 100 day, what should I say, a 100 day streak, and then you decided, yeah, I want to keep it, and then sometimes some problem came out and didn't have a free solution, and you say, okay, I need to get the premium just to see the solution. So I can see this is the business mind behind, and Christmas is coming, right? So I think their ideal is they're gonna. I think it's been like what 3 weeks, like every day, maybe a little bit over 2 weeks. Every day is easy, so it kind of just to help people build up this stream, right? To help you build up the stream. So by the time Christmas comes, it will be, I don't know, maybe 40 days streak, right? 40-ish days streak. And that will be a pretty strong incentive for people to continue using this. So my expectation is that we're gonna get easy or like a medium, but like easy medium for a foreseeable future. But it doesn't really matter to us because this is what I'm gonna do today, or at least attempt to do today. Oh, there's full screen mode. I don't need full screen mode. I mean, I do feel this is a little bit too big. Okay, I'm gonna shrink my windows a little bit smaller so I can get this one just a, dear me, just to get this one a little bit bigger. Okay, I like this. All right, let's go for it. What is today's uh, element appearing more than 25%? Given an integer array sorted in non-decreasing order, right? Non-decreasing, so it's increasing or equal. There is exactly one integer in the array that occurs more than 25% of the time. Well, we can calculate how many times it is more than 25%. Return that integer. So um, they say exactly one integer. So we know the number and we can get 25%, right? So 25% is 1 over 4. So we can divide it by 4, right? And if we integer divide by 4, and then we plus 1, so then the larger equal to that. Or we just integer divide and then larger than that. Yeah. And then we have to count. And it's already non-decreasing, so we don't even have to sort it. Yeah, it's kind of already getting. Yeah, this is easy. This is definitely a very easy one. Uh, and then there's, oh my god, yeah, this is a new laptop. Have to verify everything. Yeah, there's nothing special about this one. It's just straightforward. We're just gonna power through this, and we'll go with the real deal for today. So it's already sorted. So hold on, let me get this one a little bit smaller. So what I can do a count, right? And I can do a target. Right? When target will be this dot length divided by 4, and we need a counter larger than this target. Then we just go one by one, and we can go from, actually I think we set count to 1, right? And then we're gonna go from the second one, right? We're gonna go from 1 array dot length and then I plus plus, right? And then we're gonna say if array I is equal to array I minus 1, right? If that's the case, we say count plus plus, and then we check if count is larger than target, right? And then if that, we just return array I, because it says only 1, exactly 1 integer, right? Otherwise, if else we say else, right? Else if it's not, the array I is not equal to the previous one, so we're gonna reset, right? We reset count equal to 1, and at the end, there's actually nothing at the end, because it's we still have to return something. I'll just return -1. Doesn't matter. We will not return -1 for sure. Oh, I forgot the, hold on, 32J. Okay, now 16K. All right, this shall be right. Oh my goodness. Oh my, our target is, wait, hold a second. Oh, damn. My bad. Yes, that's right. I forgot to check at the end. My goodness. Yep, so we have to check if well, that was an oversight. That was an oversight. That should return the last one, right? Last one. I is out of scope, so I have to do array dot length -1. That was so. Alright, that was bad. That was very, very bad. That was very bad. I forgot. And I was too confident. Didn't run the test case. Should have run a test case. Alright, anyway, that's fine. So I get this done, and then we're gonna move on. Nothing too special. Nothing too special. But if this is a contest, they're gonna really, I'll be really cranky. If this is in a contest, like, such a simple one, and then you got it wrong. All right, so what is this one? This is 1287. 1287. Nothing more to say. We just do this. Okay, 5K0, and then we're gonna do here 11. Okay, done with this. All right, let's try this one. Robot, Jesus, Robert, and definitely we use Python for this. Okay, there are n. You're kidding me. One index. I hate it. This is like added complexity. Like, they don't need to add this type of complexity, but they just decided to, we want, and let's remind me later for this. They just artificially trying to make the problem a little bit more complicated. So we have n one index robots. Each having a position on the line. On the line health and wait, hold on, what? Each having a position on a line, health, and movement direction. You're given 0 index into array, positions, health, and the string directions, direction either left or right. All integers in positions are unique. Okay? All robots start moving on the line simultaneously at the same speed in their given directions. If two robots ever share the same position while moving, they will collide. If two robots collide, the robot with lower health is removed from the line. And the health of the other robot decreases by 1. The surviving robot continues in the same direction it was going. If both robots have the same health, do they annihilate? Yes, they annihilate. They're both removed. Your task is to determine the health of the robots that survive the collisions in the same order that the robots were given. That is, final health of robot 1 if survived, final health of robot 2 if survived, and so on. If there are no survivors, return an empty array. Okay. If they do not survive, then we just remove them. Okay. Return an array containing the health of the remaining robots in the order they were given in the input. After no further collisions can occur, the positions may be unsorted. That's fine. Yeah, this doesn't really matter. Position sorted, we probably can sort it if we need. So in this scenario, everybody going right, so everything should be the same. It's exactly the same. Okay. All right, now we have collision. So these two collide, so they're gone. These two collide, this is gone. So we need to return one value with 14. Okay. Example 3. These two collide, they are gone. They always give you useless, right? Useless. Hello to you. They always give you useless things, examples. All right, we have 10 to the 5th. Position.length equals 10 to the 5th. Health doesn't really matter that much, I suppose. And then left and right, all valid position. Okay, so the only one that we can really use is this, right? Let me get our pad out. So what do you think? So we have some robots, right? We have some stuff along the line. Okay, some going this direction, some going this direction. You know, it doesn't really matter what. And we want to know the fate of each one. Okay, we want to know the fate of each one. And simulating is not going to work because we have too many of them. And so sorting them by their position is definitely necessary. Okay, so we have, let's say we sort the positions, and they say we need to return in the original position, right? No, not the position. Return in the same order the robots are given. So we have to sort it and then save their position. That's fine. Save the indices. That's okay. And then so we have the one on the leftmost. And of course, if the leftmost is going left, then boom, we've done it, right? That's a trivial case. If the leftmost is going right, then we need to check, because if it's going right, then we check the next one. If it's also going right, then there's nothing we can do. Now we check the next one. So we go. We find the first one that's going left. So we can put these in a stack, right? Let's say we have health, so the position is 1 indexed. Position is 1 indexed. Yeah, that's fine. I don't really care about the position. I'll just call them the health, right? The health, H1, H2, H3, So if we have a stack, if we go right, we push in. If we go right, we probably push in both its health and its position. Okay, and then the next health and position. and then the position is increasing. Okay, so we keep pushing until we find some HK with position K. It's going left. So all of these are going right. So we find the first one that's going left, and then we're gonna pop. Right? We're gonna pop. So we'll pop this out, and they will be the first pair that annihilate each other, right? And if they are the same, they annihilate, then we don't record anything. And if this one gets annihilated, then this one, the health will decrease, and then we go for this one, and then we just keep popping until if everybody's popped, then this one survives, right? If everybody's popped, this one survives. So we have a survivor along the way when the stack is empty, right? And then we'll have survivors when we go through the entire thing, and then we have still some in the array, in the stack that's going right. Okay, I think the solution is starting to shape itself. Now I have one more, is this position. What does this do? I don't think the position does anything because they move at the same speed, right? And we sort the position from low to high. So when you have one go right and the other go left, and then have a smaller one going right, bigger position going left, and they are bound to meet each other, right? And when they meet each other, if the going left wins, it will keep going bounce with another one. So yeah, I think that's about it. I think we can try. This is 2751. No, you typed the wrong thing. It's 1. Okay. Alright, let's give this a shot. So first things first, we need to sort the positions. And of course, we're going to sort them based on sorted P's. Okay, so sorted for I, P in enumerate positions. Okay, and we're going to go back here, and then we're going to say position first, I second. So we sort them low to high. Right? Okay, we have sorted positions, and we need a result. Oh, dude, the result. Damn. Ooh. So you have to go the result twice. You have to go the result twice. Oh, I don't want to. Okay? I do not want to go the result twice, but I don't see a way. So the result is going to be an array, right, for all of them, but then somebody might be 0, and hate it, but there's nothing we can do. That's fine. Let's just do this. So we're going to do 0 times lamp positions. Why don't you just end it? I can call n equal to lamp position. Right, n equal to lamp position, and this one just need to be n. Okay, so that's the result. Then we have a stack. Then we're gonna go one by one for the position. So for p, I, we probably can. Maybe we don't need this again, right? Yeah, we don't need this again. We can maybe we can do, let's yank this. Right? Maybe we can do that. Right, so we directly sort it, so we don't need this. Okay, so for pi in this, what do? We will say while stack, right, and directions while stack, and well, let's go while stack first, okay? And if directions I, right? If directions I is equal to right, then stack, nope, 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 nope. I think this one should be higher up in the hierarchy. That's fine. Let's delete this one here and go here. I think if the direction is going right, we immediately put in the stack dot append. What do we need to append? We need to append. Do we need to append both things, or you just need to append a p? Like, why do you need a p anyway? The p is only needed for you to sort. After you sort, the p is not necessary, so we can probably don't use this, right? And all we need is its index. Its index. So we'll append this. And else we say while stack, right? And so we know direction is going left, and we need its health. If its health is larger than, so we say health I is larger than, let me read one more time. It would decrease by 1, right? If the same, they both are gone. Oof. I think this we have to consider inside. Okay, while stack, let's consider inside. If health I, okay, is larger than health stack this, right? If it's this, then stack.pop, right? Stack.pop. We pop whatever it is, and health's I. Oh, we have to. I don't like this, but it's fine. We're modifying the arrays. It's okay for this. So health will minus equal 1, and then we'll try it again for the next one. We'll try it again for the next one. Right? Else if they are the same. Else if this I is equal to health stack minus 1, okay, then stack also pop, but health also pop, right? Health also pop, and we can do that. This is like a hint, equal to 0. And if your health becomes 0, you're gone, right? If your health becomes 0, you're gone. It didn't really say. It just says decrease by 1. Oh yeah, it's gone. It's fine. If you minus, yeah, I guess if you're a 1, right, you decrease 1, you become 0. The only possibility for this to happen is the other one is 0, but nobody else is 0. So this will not happen. So yeah, so if this will pop, well, after we pop, we set it to 0, right? And we have another else. Okay. Else is the current one is, then the current one is gone. Then we say health I is equal to 0. I think it's here. I know. And health is I. If the current one has health, we keep going. But if the current one does not have health, then hold a second. JJ. Health is, and we shall say stack. Health stack minus 1. This shall minus equal 1 as well. because they collide. And whatever is on the stack, that one should decrement by 1 as well. Okay, so we go through all of this, right? We go through all of this, and we come out. So either stack is empty or health is empty. So we say if health is I, right? Which means we have health, but stack is empty. In this case, we can say res I equal to health. Oh, in that case, we don't even need res because the health I already records everybody's health. So we don't even need. Okay, so in this case, we don't even need this. We just go through this, right? And we are done, right? We're done. It's just gone. Stack is empty, so somebody has a health. So we just go through this, and we go through every single one, right? And then the next one comes in. If it's also pointing left, that means, you know, it didn't go through anything. And at the end, what we're gonna do is return this h for h in health if h is larger than 0. That's it. That's what I think. Okay, so let's delete these 2 lines and run this. Let's see if it's correct, at least if the test cases are correct. What the hell? The second one, the third. Ooh, that was ugly. Oh, I forgot this. Yeah. Hold on. Yeah, it's health stack -1. Oh, I didn't do any of those. All right, hold on. Yeah, this is not right because I didn't do any of the other things. So we have to first do this health, right? This equal to 0, and this is the same thing. Health equal to 0. Yeah, it looks like you're repeating yourself. I am repeating myself, but it's hard for me to write the same condition for these two. These two are the same. This could be larger equal to, but this is a minus equal 1. This is a 0. What I'm supposed to do? Yeah, there may be a way to do it, but all right, let's try this one. All right, this one's right. Let's go for it. You didn't even need to use the n. I don't think I even used the n. This n is not even necessary. All right, this is one of the easier ones. It's definitely not hard. Come on. We've done some hard stuff. Okay, this is not hard. This is just what we call this? Just a stack, right? This is just stack. It's nothing. It's just a stack. It's just a stack. This is one of the easier hard problems. It is nothing more than a stack which has certain resemblance of the process of constructing a monotonic array stack. We keep all the robots and we sort, right? We sort the positions from small to large and go from left to right for each robot going right, we immediately push its index to the stack. For each robot going left, we check with the top of the stack, right? And perform collision logic. As collision happens, we modify health's array in place. Once the entire positions are iterated, once we iterate through it, once we iterate through the entire positions, we will have the updated health of each robot. The answer is the health array without the zeros, the ones with 0 health. Done. O and log n plus n, you can call it, right? Let's just call it 1 log n, right? Alright, we're gonna check the solutions real fast and call it a day. Yeah, it's definitely one of the easy ones. Let's check Lee. Yep. Very rare. Like, my logic is almost exactly the same as Lee 215. And dude, I think he's still using Python 2. This, continue. Wow, this, and wow. Yeah, it's very rare. It's really, really rare that I have almost exactly the same thing. Yeah, he used to be very cryptic. That's for sure. All right, so we're done with this. What's the time? 32 minutes. Probably do one more. Oh my god. Oh my god. What the hell? What? Oh, I have a giant streak of 4. I was a premium member because I have a lot of coins. So I was a premium member for a month, and that month was very helpful. It helped me land a job. I mean, basically that's it. I spent that month just doing a lot of JavaScript because the job requires JavaScript. I kind of say I know JavaScript. Anybody who says they know JavaScript does not know JavaScript. I mean, as awful as a language it is a very, the water in JavaScript is very, very deep, very deep. I think I probably know, like a tiny little bit, and like you can see, like I know, say 1% of JavaScript, and after that month of practice, I know 2%. So I double my knowledge, and it helps tremendously in the interview. But after a month, I give it up. Anyway, let's just do one more easy one, and then we'll call it a day. Let's see if we can do it in 5 minutes. Probably gonna take me 5 minutes to understand the problem. Longest even odd subarray with threshold. You're given a 0 indexed integer array nums and an integer threshold. Find the length of the longest subarray of nums starting at index L. What the hell is L? And ending at R. That satisfies the following. You need to find this, right? You need to find the length. So at the L has to be an odd, and for all indices I in the range, this is inclusive. I is not, so that's the alternating, right? So if L is even, then L plus 1 has to be an odd. For all indices I in the range, L to R whole. Wow. So L to R, every value has to be smaller equal to the threshold. Return an integer denoting the length of the longest such subarray. Oh, interesting. So in this case, 3 to 5. Oh, small equal, yeah. 3 to, oh, cannot start with 3. It can only start with 2. Ah, I see. This one is only 1, I see. This one, so we can start with 2 or 4. So it's only 2, we have 2, 3, 4. But 5 is, okay. Yeah. What do you think? Usually for this, I don't know. What do you think? A sliding window? Would sliding window work? I have some value, some value, some value, some value, some value, right? And then we find the first even, and we check the next if it's odd and within the threshold. We'll extend until it's out. Okay, so this is out. So this is our current length. And if it's out, then we cannot do anything about it. No. It's out. You have two different types of violation. If it is bigger than threshold, then it's an out. You basically start fresh. Right? You basically have to start fresh because you cannot include this. So none of the previous will work. But if this is no, it's the same. Like if we have even, odd, and this, but instead of even, this is odd, right? This is an odd, so you cannot use this. So you have to skip it. If even, odd, even, and this become an even, then you also can, but you can start with this. I see. So you find an even, you try to extend it as much as you can, and that will be the length. And whenever you fail, depending on the failure, if the failed one is an even, then you start with this again. If the failed one is an odd, you have to skip it. And we need a length. See, this is a interesting question. Interesting. It's a good easy one, I think. No. Okay. This is a count. Result. And count should be 1. Okay. Oh, that is not right. That is not right. No. We should do. This is 0, and we go from 0. Okay. All right. Here's the thing. If nums I is larger than threshold, if it's larger than threshold, then without question, okay, without question, C will equal to 0. We reset, and we'll reset, and we'll continue. We also need a low. I also need a low. Okay. Then if nums I is even, is an odd, right? And nums I minus 1. Hold on. It's actually a lot of things. There are a lot of things going on. If this is odd, right? If this is an odd value, then if we don't have, if c is equal to 0, oh, we don't need to count. We have a low. Low shall be I plus 1. So if low is equal to I, which means you start with, then that's not possible. Then what we'll do is low will equal to I plus 1, and we'll continue, right? And else, if low is smaller, right, which means we have something, then we need to check if the previous one, right, if the previous one. So that is else if nums I minus 1. Man, this logic is complicated. If this is equal to 0, right, then we'll continue. But if this is not equal to 0, right, if it's not equal to 0, so in that case, right, in that case, if the previous one is not equal to 0, so we are not repeating, right, we are not repeating. In both cases, we shall do this, which means yank or right, wait, hold a second, why? I was trying to, find the wrong thing. Right, so if it's equal to, or that's if it start with an odd, or the current is odd and the previous one is also odd, right? And if this happens, then we have to reset. Oh, before reset, we shall update res minus low plus 1. Not really. Damn. Because if it's starting with an odd number, and it doesn't count. How can I express this? I hate this. Just make this even more complicated. Else. It's actually an else if. Right? I think it's an else if. Same thing. Let's just else it. So if low is equal to I, or nums I minus 1, right? Mod 2 is not equal to 1. In both cases, now rest can be a math.max rest and I minus low plus 1, and low will equal to I, because this could be the start, and continue. So we don't need this continue. And at the end, we'll return rest. Okay, what does this look? Does this look right? No, it does not. Something is not. Oh, yeah, this one is right. So we're gonna delete this one. Okay, we'll go through the logic one more time. So we start with, if it's larger than the threshold, we reset the low, right? If its current is an odd value, so we check. If it's the start, then we can now do. Or if the previous one is not an even. In both cases, that's like we're done, right? We're done. Then we need to update the rest. But to update the rest, we have to be careful because we cannot do 1, because the current one can still be 0. And then after do that, we'll set the low to the next value. Or if the current one is an even value, then we'll do the same thing, but we can set I minus low plus 1. Okay, let's give this a shot. Looks okay to me. Looks okay to me, but let's go for it. That's not right. All ones. That's not right. How? So we start with 3, right? So 3 doesn't work. 3 is this, and low is equal to I, so it doesn't work. So low become 1. Okay, so low become 1, and we go to the next one. That was 2. Okay, low is equal to I. Yeah, that's fine. And then it's this. Oh, there's nothing to. No, it's fine. So low is equal to 1. It's still equal to 1. So next is 5. 5 comes in as this. That's false. That's false. So we don't do anything. The next come in is 4. Ah, you forgot to do it at the end again, man. It's like the second time. Second time today, you forgot. So at the end, you have to do one more computation, which basically means we should return math.max res, and because we go all the way to the end, right? We go all the way to the end. So it shall be the last value minus low plus 1. So nums dot length minus 1 minus low plus, does low equal to nums dot length minus 1. Right? If it's equal to, oh god, oh god, this is. I wish I could have one more. Just add one more to nums. That will make things so much easier. Because at the end, I have to check again, right? If the last one is even, then we just do this. If the last one is an odd value, but why the third one, why this one still doesn't work? Huh? Oh, because I forgot to do it here. Good point. That is a good point. So we should do res equal to math.max I minus low plus 1. Right? Doesn't really matter because it's larger than the threshold. But at the end, when you get out, okay, we have a low, right? And we'll check. How do you check? Miss minus low. Yeah, I think that's fine because if the last one is like in this case, it's already handled, right? The only thing that's not handled is I think we can just say plus 1. I think this is fine. See, this problem, I feel like it's more complicated or not as easy to solve as I had expected. What? Gosh, yeah, you gotta be kidding me. Oh, yeah, because at the end. No, I updated, right? I updated this. The last one's 5. So I minus low plus 1. Oh, I is not part of it. Oh. We shall not include I. But these are also we should not include, right? Yeah, I think so. I think we should not include this either. Okay, let's see if we can get in one shot. It's actually quite complicated, honestly. It's definitely not. Logic is not really that easy. Hold on. So 60. Not that easy to write. Oh, do you have like an easier solution? I just feel this is so awkward. But I don't know. It's all right, right? It's all right. We know what this entails. if low is equal to I, what I'm trying to do is I'm trying to summarize the previous one. So it should be I minus 1 minus low plus 1. Should be I minus low, right? I'm only summarizing the previous one, which means I think I can just do I minus low. Yeah, I think this is all I need. Right? Can you further make it? I can. I can make it. Yeah, but I guess it's fine. I'll just submit this way. All right. Anyway, that'll be it. I thought I could solve in 5 minutes. It actually took 10 minutes. Ugh. The copy never works, does it? All right. That'll be it. Do we go through this? Sliding window. ON. We take this, or we take this. If this is true, wait, hold a second. Count, I think, is the current count, right? Count is the current count. And if count is equal to count, if count is equal to 0, which is the start, and if current one is an even, then count become 1. If current one is an odd, then we will check. Right, we will check L minus 1. How do you make sure? Because the first one is equal to 0. Got it. Otherwise, we'll check the previous one if it works. Oh no, so this is wrong, right? If it's wrong, then we say is the current one an even one, and we basically reset the count, right? We reset the count. Otherwise, count or plus equal 1, and we check the max every single time. It works. It works, but I'll stick to my solution. All right, that shall be it. I just deleted what I did earlier. I'll see you guys tomorrow. Adios.